Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 1319, number of operations to make a network connected. This is a medium difficulty graph problem. We're told that we're given an n number of computers, numbered from 0 to n minus 1. So we're given a list of computers connected by Ethernet cables, connections, forming a network where connections equals A and B, so it's a list of a 2D list, which represents a connection between the two computers, and basically this whole list represents a network, and any computer can reach any other computer directly or indirectly through the network. So it's not a directed graph, it's an undirected graph. We're told that we're given an initial computer network of connections, and we need to extract certain cables between two directly connected computers. We can extract certain cables between two directly connected computers and place them between any pair of disconnected computers to make them directly connected. So this makes more sense when we look at a diagram. So in this diagram, we have n, which is the number of computers, and we have the number of connections, and we can move the connection from 1 to 2. So we can scribble out this connection and instead put a new connection here. So this is our new network. We can do the same here as well. So in this example, we can make two new connections. So we can cut off these two connections over here, and we can make a connection to 4 and a connection to 6, or a connection to 4 and a connection from 3 to 5. Either way will be fine. And in this example, we're also told that we return -1 if there's not enough cables. So in this example, there aren't enough cables. And why aren't there enough cables? Well, we need to have a basic understanding of some basic theory. So I'm going to draw some computers to kind of understand how many connections we need. So let's say we have, 3 computers. So we have 3 computers, but you'd think maybe we'd need 3 connections, but that's not true. We'd only ever need 1 and 2 connections to make a network, to connect all the computers together. So, even if we add a 4th and 5th computers to our network, and let's say we add new connections, we're never going to need 4 connections. We're at most going to need n minus 1 connections. So n is the number of computers, so the number of vertices, and the number of edges, it's always going to be the number of vertices minus 1. So that's how we can calculate if we have enough cables for our network. So in this example, we have 4 cables, and we have 6 computers. So 6 minus 1, that's 5. So we don't have enough cables. There's not enough edges, basically. So we return -1. So we can basically, if you've done any kind of like counting components problem before, it's basically doing this basic checking that we have enough cables to build our network. And then once that's done, then we just calculate the number of components and return that. And that's going to be equal to the number of components minus 1 again. So let's actually get started. So how can we first check that we have the necessary number of cables? So we can just say, if the length of connections, is less than n minus 1, then we return -1. So straight out of the box, we've handled this edge case. So now we can actually start counting our components. So we can build our adjacency list. I'm going to call adjacency list. That's a default dictionary of lists. And we're going to say for A and B in connections, we want to build our adjacency list. So A.append B, and then the same vice versa. Remember, this is an undirected graph. And now we want to count all the components. But before we do that, we want to also add a visited set, so we don't, not only do we not get cycles, but we prevent visiting nodes that we've already visited before. So we're going to set visited equal to a set, and k is going to be equal to initially be equal to 0. And now we need to iterate through all the nodes in our from I to n. So we're going to say for I in range of n. If I is not in our visited set, well, now we need to do a couple of things. We found a new component, so we're going to say k plus equals 1. Oh, and this is probably, it's a bit vague, but remember that k is going to be the number of new edges, so the number of new cables that we need to make the network whole. So it's important to remember that. So if I is not in visited, k plus equals 1, we're going to say, let's create a breadth first search queue. But before we do that, we want to say visited.add. We're going to add the current node to our the current node to our visited set. And we also want to now do breadth first search. And breadth first search will basically just mark off this entire component so we don't visit those nodes again. So we're going to put in I, and then we can just do some basic breadth first search. So we can say while q node is going to be equal to q.pop, and we can now iterate through all the neighbors for this node. So we're going to say if for neighbor in adjacency list node, if neighbor is not in visited, we can say q.append and append our neighbor. And we can also add to our visited set our neighbor as well. Remember, we don't want cycle. Visited.add neighbor, and then we can return k. So return k, but remember, we need to return k minus 1, not k minus 1 is going to be the number of cables that we require. So let's run our code. Let's check this code works. And it does not, because we have a bug somewhere. K plus equals 1. While q. Okay. Okay, so we're building our for I range of n. I said to return k minus 1 and I just returned k. Okay, that passes all test cases. This is literally what I've been saying for this entire video and I did not adhere to that. Apologies for that, guys, but we can see that we passed all 36 test cases that are required to solve this solve this problem. So with that being said, I hope you guys enjoyed this video. A bit of a difficult one, but comprised of two main parts. First, doing this check for the edge case where we don't have enough cables, and then just counting the number of components and returning k minus 1. So I hope you guys enjoyed this video, and I'll catch you in the next one.